welcome back. It's great to have you here to do some revisions on straight lines. We will be going through some examples together. Please get your pen and paper ready and work through these questions with me. Y equal to mx plus c is the general equation for straight line. M is the gradient and plus c is the y-intercept. Let's see the graph of a straight line. It might be going up, going down, or stay horizontal. If it's going up, the gradient m is greater than 0. If it's going down, m is negative, and if m is 0, that means it's horizontal. Y equal to a constant. As you can see, y-intercept, which is c, it might be positive or negative. And we also have the x-intercept. So now let's look at the parallel lines and perpendicular lines. What's special about the gradient? As you can see here, I have line L1, L2. If they are parallel, their gradient are the same. And if they are perpendicular, their gradient are negative reciprocals. M1 times M2 equal to -1. Okay, so now let's look at some very useful formulae. So let's start with the gradient. M is the gradient. To work out the gradient of a straight line, we need 2 points. I need to do y2 take away y1 over x2 take away x1, or the other way around, it doesn't matter. One thing we can't do is we do y2 minus y1 over x1 take away x2. I can't mix match them, so I have to make sure the order is the same. As we mentioned earlier, plus c is the y-intercept. That plus c can be positive or negative. Y-intercept means that x equal to 0. And if I wanted to find the x-intercept, then I needed to make y equal to 0. So now let's look at the coordinates of the midpoint. So to work out the midpoint, we need to half x1 plus x2, half y1 plus y2. So to work out the length of line segments, I needed to use Pythagoras theorem. So as we can see on the board, what we need to do is to find the difference in x and the difference in y. Let's look at some examples. Please do pause the video, have a go, see if you are able to work out the answer. So the first question asks us to find the equation of the line that passes through these 2 points. I needed to work out the gradient. And what we needed to do is to find difference in y over difference in x. So in this case, m is 8 over 5. And then what we needed to do is to pick a point. So in this case, I pick point B, but it will give you the same answer if you use point A. From point B, I know when x is 5, y is 13. So now what I needed to do is to substitute 13 and 5 into the equation y equal to 8 over 5x plus c. And then that will help me to find c. In this case, c is 5. Therefore, the equation is y equal to 8 over 5x plus 5. I'll move on to the second question. We wanted to find the perpendicular bisector of the line AB. A good way to do this is to get yourself a sketch. It will help you to visualize the problem. And you don't have to plot your point exactly, just a rough sketch. So from my equation, I know my gradient is positive 8 over 5 and my y-intercept is 5. So now perpendicular means that my lines has negative reciprocal gradients. M is gonna be -5 over 8. So now I know the equation of the perpendicular bisector is y equal to -5 over 8x plus c. So now in order to find c, we need a point. Bisector means that it's in the middle. So we need to find the midpoint of A and B by using the formula half x1 plus x2, half y1 plus y2. That will give us 0, 5. So my line passes through 0, 5. So what I need to do now is to substitute this point back into my equation, y equal to -5 over 8x plus c. 0, 5 is the coordinates of the y-intercept. Remember, y-intercept is when x equal to 0. So that means c is going to be 5. So then I can just write down the final equation, y equal to -5 over 8x plus 5. However, if that point is not the y-intercept, if it's some other points, then what we can do is we can substitute x and y back into our equation. That will allow us to work out what is c. So as I have done here, we can check that we got the same equation by using 2 different methods. In the third third question, they want us to work out the area enclosed by the lines and x-axis. So with this type of question, it is a very good idea to get ourselves a sketch. So then we can see what does the triangle look like. I've got the straight line AB, and then we also worked out the perpendicular bisector. I can add that line to my graph. And then in part 2, we also worked out the equation of the perpendicular bisector. So I can add that line to my diagram. So now we can see what this triangle looks like. I'm going to add some letters so then we can name them more easily. Okay, so with this question, we have 2 different methods. So I'm going to go through both of them. Please have a go, see if you are able to work it out yourself. The first method, we know that to work out the area of a triangle, we need the base and the height. So I needed to do half base times height. In order to work out the base, I needed to work out the coordinates of C so that I know the length from C to O. In order to find the x-intercept, we need to let y equal to 0 and solve for x. So 0 equal to 8 over 5x plus 2 because it is a point on the line AB. So we needed to use the equation of the line AB. And then we worked out x is negative 25 over 8. The distance is positive, which is 25 over 8. Similarly, we needed to work out the coordinates of E because we needed the distance of OE. So again, I let y equal to 0, and now this time it is a point on the perpendicular bisector. Therefore, I'm going to use the equation of the perpendicular bisector and work out that E is 8, 0. Okay, so now we've got the base. The base is OC plus OE. That CE is my base. And what is my height? My height is OD, and we know what is D. D is 0, 5. Therefore, the height is gonna be 5. So what I needed to do is to put that into the formula, half base times height, and then we can work out the area is 445 over 16. CDE is a right angled triangle. I can do half of DE times CD because that is my base and height. So in order to work out the length of CD, we now have the coordinates of C and D. To work out that line segment, remember what we needed to do. We needed to use Pythagoras theorem. The length of CD isn't a nice number, but keep it in its exact form. Keep your square root. Don't round your number too early. Otherwise, we won't get accurate answer in the end. And then use the same method, we can work out the length of DE. So what we needed to do is half DE times CD. So we can check that our final answer is the same as the first method, which is 445 over 16. That's all for today. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport. You have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.